Hi friends, in this video we'll discuss about the capillary action and how to perform it in using Ansys Fluent. So I'll just show you the simple capillary action when you try to immerse any vertical pipe inside a beaker. So now you can see when you try to immerse anything inside a beaker, the water level would rise, right? So the water level rises due to the adhesion effect between the capillary wall with respect to the water. Now, if I can state, this is the term that defines the forces that would be generated due to the surface tension inside an Ansys Fluent or inside any commercial tool we use. So this is a P2 minus P1 equals to surface tension into 1 by R1 plus 1 by R2. R1 and R2 are the two radius vectors perpendicular direction. So if this is R1, this would be R2 along the curvature. So you can state if R1 is equals to infinity, if it is a flat surface. So if it is a flat surface, then R1 is infinity. Radius would be at some infinite point. So then this becomes 0. So then there will be a no surface tension force. So a surface tension force would be coming into act when and only if you have any radius curvature. So this type of radius can occur when there is an extra amount of adhesion or extra amount of pull that would pull the water with respect to the wall. So if the wall try to pulls it, so initially it's a flat surface. Now if wall try to pull it, what happens? It tries to tend in this curved format. So as it tries to tend in the curved format, so now we will get R1 and R2. So when R1 and R2 exist, so there is a force term called surface tension force. So due to the surface tension force, the entire liquid, what the liquid you are seeing here, this is everything is liquid, water liquid or anything, any liquid. So it tries to move in the up direction because due to the surface tension force that has been coming into act along with the wall adhesion, which is resulting in a force, net force in the upward direction. So the entire water column would move until it is been balanced by the weight in the down direction, right? So that force term would be added as a source term to the Navier-Stokes equation or the momentum equation that we generally solve in the CFD. So this source term would be added. So we all know the Navier-Stokes equation, what we generally use. To that we will add this source term. So that is xt or source term that is due to the surface tension. So in some cases the surface tension would be tending to 0 when the wall adhesion effect is negligible. So here we can state that the wall adhesion would be very much high near to the wall, but away from the wall, here there would be no curvature effect. So if there is a no curvature effect, so it will not pull in the up direction, so it will be remain flat. So in terms of knowing the R1 and R2, here is some terminology what generally Ansys Fluent will use. So this N is a normal. That normal is been defined using the gradient of alpha Q. Alpha Q is nothing but volume fraction. So if you can take the curvature, one side would be a gas, another side would be a liquid. If you take air and water, so alpha L is in water. So with respect to gradient, so alpha L will have some value here, might be like if you can say here it is 1 and here it is 0.9. If you go up to this point it would be 0. So this gradient would gives the normal direction, right? So that N and K which signifies the del operator which gives the source term F wall, what you can see here. So sigma ij is nothing but surface tension coefficient. This ki would give the directions, or and this delta alpha I is nothing but the grad of the diverge. Grad of the volume fraction. Rho is the combined density. Combined density, it means at the curvature what we can see is alpha 2 rho 2 plus 1 minus alpha 2 rho 1. So it is a mixed density that is present near this curvature, and alpha I and alpha j are nothing but the densities of the either of the fluids, right? So this is the net force that would be generated. So this force is replicating this formula only. So alpha j and 1 by rho 1 plus 1 by r2 is nothing but is the entire term which signifies the radius vectors. So this would be added to the Navier-Stokes equation F wall. So due to this net effect, the entire liquid column would be pulled up, which until it is balanced by the self weight, right? So we'll just try to mimic this principle in Ansys Fluent. So I have created this with a fine mesh. So this is the column, and I'll try to pass water up to this level. So I'll activate a transient mode, click on gravity minus 9.81, and in the materials I'll just assume it is a laminar flow. Next, activate multiphase. You can go for a volume of fluid also, but I'll just going with the Eulerian model, which is much more accurate. So it is due to the accuracy only I'm just going, nothing else. Close it, go to materials tab, try to import water liquid, go to Fluent database, drag drop, go to water liquid, copy, close, close. So go to multiphase. The phase 1 option give as air as the fluid. In the phase 2 it is water liquid. The phase interactions you can just leave. Maybe this one you can just give tonium et al. With hydraulic diameter. I think it's not necessary here. And surface tension coefficient is important. Constant value is 0.072. Surface tension modeling, this is very much important. Wall adhesion, so what is the angle what you want to give? So wall adhesion, and give, try to apply, and then just close it, go to boundary zone conditions. So inlet, there is no inlet here. I have named this point as inlet. So just that inlet is nothing but a outflow condition. You can give an outflow condition. So go to boundary conditions. Inlet is nothing but outflow. Outlet is these red lines you can see, right? This side and this side, both are also outlets only, or outside outflow condition. Outflow, right? And in the wall, double click wall. So we need to define the angle. As I mentioned here, this angle is important. That angle signifies the wall adhesion. So with what force it will try to pull. So I'll just give wall adhesion as 30 degrees. Click OK. Right, now go to initialize. Click on initialize. So everything is initialized with 0. So you need to patch it with water. So you need to have a water level up to this. So go to refine coarsen. As the geometry is defined by me, I have know the limits of the geometry. So go to new region. I'll just convert this into mm. Units. Length in mm. Region. So it is minus 40 plus 40 minus 20, and this minus 15. We can just check, don't worry. I think this should also be minus 40. Yeah, now it's perfect. So I've created that region. You can just click OK, go to patch. So we'll go to phase 2, volume fraction, and I'll try to patch that region with volume fraction 1. Patch it. So only this region is patched with a volume fraction of water with 1, and remaining everything would be air. Just check for your confirmation. Go to counters, click on interior surfaces, faces. You can leave that. Save display. So you can see air is topmost and water is the bottom one. Go to run calculations. I have created 118 1 e power minus 4 as my time step with 1000 as the time steps. Click on calculate. So I have ran it through quite a number of time steps. So I'll just try to show you the phase fraction. So you can see on the screen, right, how the volume fraction, how the water level is been going up compared to the previous level, what it used to be. And this height rise is also due to the wall adhesion, but is most significant here. I'll just click on the phase fraction just for having a values. Can apply. So this is after a few number of time steps. I'll go to the initial time steps so that you can understand how exactly it is been varied. So this is the initial condition after few time steps. After a few more time steps, you can see there is a validation that is pulling up. After a few more time steps, it's moving up, and at the end of the final time step, what I have selected, move to the gate extent. Still it can has the ability to move until it is balanced by the self weight. So I think this video has helped you how to perform the capillary action inside Ansys Fluent. I request you guys to please do subscribe the channel and encourage me in doing more number of videos. Please, I request you to subscribe. Thank you.